Yeah, so I proposed this talk, getting started with Coretime, and was leaning more towards deeper discussions of topics and examples of how to get started. But after a few discussions in the summit the other day, and after the workshop, I've kind of retooled it slightly to be a bit higher level, with less of an emphasis on the usage of it and more about the implementation, because I think that it's at an earlier stage than I had originally expected. So I was up to like 3 last night, just retooling the slides. So yeah, getting started with Coretime was the original title, and it's more like introduction to Coretime. So anybody who was at the summit the other day, this is pretty different talk, even though the first few slides are shared. So yeah, I will get started. So just an overview of the talk. First of all, I'll just motivate a little bit why Coretime is necessary, or why it seemed to be necessary. I'll go through the specification in terms of the RFCs and just boil those down into layman's terms or close to it. And then I'll go into the implementation details, which are, I think, the most interesting parts. Well, apart from the pricing. Pricing is my favorite at the minute. But the implementation details are things that weren't fully specified by the RFCs. And so it'll be interesting to talk through those. And after that, we've got the status, so just like an update of where we're at with the different test nets and with Kusama and Polkadot, because I think that's going to be really crucial for everybody's planning. And then we'll go into pricing with a look specifically at the Kusama runtime, because this is the one that's going to be released next, and it's the first one where the pricing is a real consideration, because obviously on Rococo there is the token itself has no external worth. And so you might have seen there that the prices have been these insane runaway prices. We've dumped loads of cores on there just to allow people to experiment. So don't believe what Rococo tells you. That's not what's going to happen on Kusama. Well, I mean, I can't definitively say that, but I think it won't happen on Kusama, at least not as quickly. So yeah, and at the end, uses and examples, if we have enough time or if people are really interested. I want to finish a little bit earlier than I'd originally anticipated, just to give more time for questions. But if there aren't any, then I can continue on and just talk through a few of the examples in terms of like the options for how you can integrate and how you can automatically renew if you want to do that, or automate the buying of on-demand Coretime. So we'll get into that. I don't want to get too bogged down in the overview. So first of all, what is Agile Coretime? So I actually think, just in light of the talk from Gav yesterday, the first thing is maybe the last thing on here, that Coretime is not, well, this is not working. Coretime is not CoreJam, and that's out of scope for this talk. CoreJam is a research project. Agile Coretime is happening. It's already like basically ready to be released, and so this is today, and CoreJam is tomorrow, a long tomorrow. So yeah, Agile Coretime is like a fundamental change in how the network actually functions. It's not just a small change. It completely changes the paradigm of how people can use and do purchase Coretime. And so previously with well, I'll not get bogged down. So it also represents a new first-class market on Polkadot, where people can, there's a new asset to be bought, and then it also is a catalyst for secondary markets. There are things like futures and options and all of those kind of derivative items that you can do, and secondary trading mechanisms. There's a really good FAQ, or there are really good FAQs that have been published by Parity. So I would recommend you all check that out, and I'll be uploading these slides somewhere after the talk. So right, the motivation. We can think about the motivation for Coretime by thinking actually about what Coretime aims to solve, because it aims to just solve the issues that motivated circular argument. So it lowers the barrier to entry for people entering the ecosystem. Previously, with the auctions for a slot, there was a requirement to convince a large number of people to lock a large amount of DOT to enable you to bid for a slot. In reality, people only bidded for 2-year slots, and that obviously isn't what most people need. And the product that you buy is a kind of one size fits all or one size fits none, where you end up with a lot of core time in the new way of talking about it. And what do you really do? If you're a small project and you've managed to get there, you've now got an asset that you may not be able to use or would rather not have because you could sell it otherwise. So this encourages people to use their block space efficiently, and anything that they don't use, resell to allow maximal utilization in the ecosystem. Because for us, like the Polkadot ubiquitous computer is running all the time, and if it's producing empty blocks, then we have just missed out on an opportunity to do kind of proper work, to do functional work. And so it also allows the flexibility that I've just kind of mentioned. So we'll get into that a little bit later, but you can for a given use case, there are multiple different ways that you want to or need to use to have validation on your work, and so this just allows you to do it in a much more flexible way that doesn't require you to have a long running slot. So yeah, okay, I just talked through this. But the second point is something I haven't covered yet, which is that when you pay for a month at a time with bulk, you're sacrificing flexibility for predictability. When you pay for what you need with on-demand, you're sacrificing predictability for flexibility. So these two things are trade-offs, but they're both allowed by the system. So this goes on to the like a secondary aim, which is that as I said, changed the slides last night. It's a bit of slide karaoke. So the secondary aims are this predictable pricing with renewals, when you have your bulk core time each month that you're up for kind of renewing your core time, you have a cap. So no matter what the market does that month, you know that you don't have to pay more than a certain bump that's defined by governance each month. And so this gives you the ability to say, I know that even if I want to run this for 15 years, that assuming no complete changes in the ecosystem, I can predict the maximum price. And then the price can be lower than that. If the market price falls, then you pay that. You pay the minimum of either your original price times the maximum bump or the market price at the time. And yeah, so these two aims, the predictable pricing and market-driven price discovery, are in tension because we want to have something where the network shouldn't just say, right, core time costs X, because there are a few different, there's like the supply and demand consideration as a kind of an internal factor, but there's also the external factor of the real world sort of fiat exchange rates that people will be sometimes thinking about. So if there's a big increase in the price of DOT, then it changes things, and likewise a big decrease. So we want to be able to adapt in line with that, but without sacrificing predictability. But it's always a trade-off. So this model is an attempt at finding the right balance between those two aims. So just going to take a step back because this is something I wanted to say, that to put a number on the kind of lost opportunity is that the median utilization of Kusama and Polkadot both sits around about 1.8%. And then if you look at the mean, Kusama is more like 13%. But if we go for the median, then we say, roughly, these numbers are obviously just thumb to the wind, but you have more than 10 million blocks in a given 2-year lease. In reality, these are the leases that we end up with. And when you take away that 1.8% utilization, you still have 10 million blocks worth of untapped potential. So it's kind of, you get lost in the scale with the utilization. So we really want to make sure that this is maximally utilized in all of the different ways we can. So there are a few things I'll talk about at the end, which are other mechanisms to improve this, but Coretime is one of those mechanisms. Agile Coretime. So yeah, you can see these numbers on the Polkadot Wire, which is developed by RegionX. It's a really nice little tool. You can just go through different parachains and just see what their utilization is in terms of block weight. So going on to the specification, I've put up the two accepted specs via RFC. We got the Agile Coretime RFC by Gavin Wood, which is the description is Agile periodic scale-based model for assigning core time on the Polkadot ubiquitous computer. So the descriptions are terse, but they're pretty descriptive, and then I'll go through it in another slide and kind of explain what the content of that RFC is, because I've heard from a few people that they're hard to read. So RFC talks about the kind of broader specification, and then RFC 5 builds on that, and this was written by Gavin Wood and Rob Habermeyer, which defines the interface for manipulating the usage of cores on the Polkadot ubiquitous computer. So this is just defining the interface between the core time chain, because it runs on a parachain, we're looking for a minimal relay, but the relay still has to do the scheduling. And so defining an interface between them means that they're decoupled from each other. So another addition to this, which came later, just a few months ago, it was actually just accepted about a month ago, I think, is what happens to the revenue from core time. Because obviously we're talking about this market price that we're trying to achieve, but the path to that is unpredictable and defined by many things that are outside of our control, and it's kind of a very complex, it would be a very complex model. So this RFC tries to mitigate that, like the impact of that on the treasury if we decided to put it in the treasury. So this proposes and is accepted that all the revenue from bulk core time sales should be burnt. So RFC 1, going into the broad strokes, this is kind of like my summary, a boiled down version of it, which leaves a few details out, but I think gives a good high-level overview. We want to minimize the barriers to entry in the ecosystem for what I've just described, for the reasons I've just described. The price predictability, no surprises here. So a definition we haven't seen so far is that it should scale well with a continuously changing number of cores up to 1,000. So we shouldn't assume any, I mean, it's a distributed system. We shouldn't assume any steady state capabilities of the system. The system should be able to change. It should facilitate the optimal allocation of work to cores. So we don't want to create a system which leads to people gaming that system, or which encourages people to do things that are bad for the utilization or otherwise bad for the ecosystem. This is a change that helps Polkadot, and it's a change that is good for the entire ecosystem. And then another one is, don't add complexity to the relay chain through core time specific logic. We want to decouple these two chains and make it so that each one can be adapted or iterated on without not being able to talk to each other anymore. More details in RFC 1. I've left a link for when I share the slides. RFC 5 is, as I said, the interface. So the first point of this is pretty dense. I've boiled down quite a few points that the RFC makes into this one sentence. So low latency scheduling on a varying number of individual cores in various allocation patterns. Reading into this a bit, low latency, we want to make sure that this can be allocated on the fly. It's agile. We don't want something that once you kind of commit to it, you're stuck in some pattern of usage or whatever. The varying number of individual cores. Individual is an important word there, that we want to be able to specify that each core should run in a generally different way. So one core might be allocated to one task. You might have multiple cores allocated to one task, or you might have one core allocated to many tasks. And you also have the option of putting them into the pool. There are different options of what you can do with your core time. And so being able to specify what happens to a core is really important for this interface. But note that we're not saying individual specific cores. That's left to the relay chain to do its scheduling and schedule it in an efficient way. A varying number of cores, already mentioned that for RFC 1. But the various allocation patterns is a really important thing, because that's, especially when we think about more generalized tasks than just validating a parachain. So that's for the core time chain talking to the relay chain, and in the backwards direction, the relay must keep the core time chain updated at all times. So this is for things like on-demand revenue and usage of different cores. There are a few other things. And then the last part essentially says that there should be Coretime credits, so that you should there should be a method of setting aside funds to purchase Coretime. And this allows for a few things that can be built around that, like adding proxies so that you can delegate the buying of Coretime without the risk that this person will just run away with the money or whatever. So again, RFC 5 is linked here. And then the RFC 10 is burn it all. So burn the bulk Coretime revenue. So as I said, it's to avoid disrupting the steady income to the treasury. We want that to be completely not a volatile thing. It should be steady and predictable. And so the so the transaction income, although it is changing because of the scale and you're talking a high number of transactions, you can predict that to a pretty good degree. Whereas with Coretime, it's by definition a volatile price, or in general, it can be volatile in price. Some secondary effects of this are that it is another method to balance inflation. The only other deflationary pressure that we have right now is burning unspent treasury funds. So to add another deflationary pressure is a good thing for the system. And the third thing is to be a clear cost, so that people don't start to think about this in terms of, okay, I'm going to apply for treasury funding in the near future. I'm paying for Coretime, but I can discount that in my mind because I'm going to just get it back anyway, or some percentage of it. And again, link to RFC 10. So I'm going to buzz on a little bit. I'm going a little bit slower than I expected. So yeah, the implementation status, I'll go through these pretty quickly, but basically we've got Coretime chain deployed and working on Rococo and West End, and so Coretime is functioning there. On Rococo, we've got a lot of cores, which I'll explain in a second. And on West End, there are no cores. It's a system parachain only network. Kusama is upcoming. The 1.2 fellowship release will include Agile Coretime. And we've just got some future improvements and additions. We've got a long list of things to improve and iterate on. The relay chain implementation status, so that was just for the Coretime chain. Obviously, the relay chain does a lot of the heavy lifting as well. So the migrations for the runtime upgrade, we initially deploy the Coretime chain, and then we deploy the relay chain, which populates the Coretime chain with all of the leases that are carried over from the old slot system. They're fully implemented. They were tested on both Rococo and West End, and are working well. On demand isn't fully implemented yet on the relay chain side. There are no Coretime credits, so you don't buy your credits through the Coretime chain and spend them on the relay. You just buy Coretime, on-demand Coretime directly on the relay for the native token. And then because of that, if you put your bulk core you've just purchased into the pool, you won't get any funds back for that because there's no way of it hasn't been implemented that there's a way to track the revenue. So yeah, we've solved the issues with the migration. On the first deployment, we realized that there were some issues with the migration, the XCM. There were too many instructions for one XCM, so we had to split it out. And then just fix a few weights that were misconfigured. There's a lot of XCMs talking between the two chains. So we fixed that, reran the migration, and didn't realize that we would then double the cores, just a small factor in the migration, which treated the previous cores that were treated the previous slots that were set aside for para threads as on-demand cores, as cores. But then when you run it again, it treats all of the leases from the previous migration as what we would previously have assumed were cores for para threads. So we had 51, and now we've got 101 cores. So that was unintentional, but I mean, there's more to sell, more to buy, and more to sell. So we've had lots of activity, and the prices have gone insane because there's no limits. So we learned a lot from the process. West End, we wanted to just have a smooth deployment with the new migrations. It was grand. Obviously, it's on a different scale with fewer parachains, but we wanted just to make sure that the weights were all correct. And the sales have started, but there are no cores to buy. So upcoming, the interesting part, we're finalizing the code in this pull request. There's a pricing model which is proposed, which I'll talk about in a second. And in the steps to launch, the way that we're launching is that we're aiming to launch, or we're proposing that we aim to launch on a lease period boundary. which means that the auctions that are upcoming can be cancelled. The system that is set, where people have leases that have already started, will be migrated to Coretime. Leases that haven't yet started will be refunded. And so these cancelled auctions will be replaced with cores in the first sale. And in Polkadot, a bit further in the future, but we'll learn from the Kusama deployment. We wanted to make sure that the pricing assumptions that we're making are going to hold. And I think that there's time to iterate a little bit on the pricing adaptation. And there'll be an RFC about this, at least one. And there are a few final audits to do. Maybe, so these have question marks. You know, if we think it's necessary, should we generalize the implementation? Should we always use the market clearing price? We'll find out about that in a second. Minimize volatility. Yeah, so look out for RFCs. So a bit about the implementation. Well, this is basically from the spec. But the sale is based on a periodic Dutch auction. So Dutch auction is from the markets in the Netherlands, where if you're selling some fish, fresh fish goes off, you want to sell all your fish. So you start off at a high price, and depending on demand, it might sell out all at the start. But if it doesn't sell out, you keep dropping the price until you hit your fixed price, which is I'm not selling my fish for any less than this, I'd rather throw it out. That's the kind of model we're going for. So if you think about this as being the start of a classical Dutch auction, we just have this renewals phase at the start where your price is the base price, and you're capped. Your renewals are capped based on the price you originally paid for your core. So after this interlude period, only renewals can happen, and then at the start of the lead-in period, you have this multiplier, which starts it off at a high price and then drops down to a price that's calculated based on the performance in the previous sale. So yeah, we're calling this the lead-in length, and then the final part is the fixed price period. And it's going to be about 7 days, 14 days on Kusama, if the proposed parameters are accepted. I'll take questions at the end if that's okay. So the way that the broker pallet actually works, the broker pallet does all of the heavy lifting for the Coretime chain. The Coretime chain is just a lightweight wrapper around that. And so we've got a tick function which runs every block and propagates and carries out the changes that we need to do in each tick. And so at the start of a sale, we'll clean up the old sale, put any unsold pools into unused cores into the on-demand pool, and then based on the price, the final price that was sold at, and the number of cores that were sold, we then calculate the price for the next sale. So you've got this Coretime NFT, which can be customized, transferred, assigned, and then you can also assign it to the on-demand pool, and we call those regions. We've got the specifics in the Rust docs for the broker palette if anyone's interested. So a few bits of nomenclature. I won't go through, I'm running out of time. I won't go through all of these, but one that's new is Coretime vouchers, which will be implemented soon. So it's where a benefactor can buy Coretime vouchers and gift them to people at, say, hackathons and say, here you go, here's some on-demand Coretime that you can redeem without having to spend any dot. But again, it means that they can't just go and cash it out. And yeah. So talking about bulk, we've got time slices, which is an 80 block long period of time. So this is the part that is scheduled each time. So you schedule a time slice in advance, and you can split that time slice up in various different ways to have multiple tasks assigned to the same core. And that's allocated with a mask, which is an 80-bit string, a binary string. So you just have a 1 if you want it to be scheduled, and a 0 if you don't. And so if you split your region out, the masks should all exclusively OR together to make a complete mask of ones. Bulk, you know what that is, and region I've already described. Really running out of time. So splitting, interlacing, transferring, this is maybe details that I can skip. That's definitely a detail I can skip. If you want to look at it, it's a better mental model for why it's called a region. I've heard loads of people saying it's a confusing name. I don't think it is, but I was a physicist once, and so maybe I just think about it in a weird way. Renewals, already described that. Migration, grand. Pricing, don't have time. So, sorry. That's it.
Okay. Thank you for your explanation. Do you have any questions?
Yes.
Hi. So you mentioned a slide with the graph for pricing. Yeah. So yeah, that one. So will the renewal price always be lower than the base price, or is that just happens to be this way in the slide?
That just happens to be this way to demonstrate that the renewal price can be less than the fixed price for that period. I think that if we had shown it as the same, it wouldn't have been as instructive. So this is, given that you've bought bulk Coretime in a prior sale, the kind of feature we're trying to point out here is that you have a cap, so you don't necessarily have to pay the market price. You can pay a lower price. So this is like one possible sale price. This is the same for everybody. This differs depending on what your original price was.
Okay. So it could potentially be higher than the base price as well, then, right?
No.
No.
No. So that's what I was saying. That you take the smallest value between the market price and the renewal cap.
Okay.
So the cap is a cap. It's not a fixed price. So that's what I was saying. If you can predict your maximum expenditure over the years, but you might actually save some money.
Okay, thank you. We have a last question, please.
Yeah, so two small things. One question is, first of all, is you mentioned 2% approx of block utilization. What do you think it's going to be with Coretime? Because it might be that it's not only because parachains are not using space, but also because Polkadot is not being used. So which are your expectations? So which is the change you expect? And then which is the deflationary force you expect from burning the revenue? Thank you.
So to answer your first question, I think it will go up, and that's the basic answer. Because if we don't see the utilization of the cores, the expectation is that the configuration can be set in governance that we sell fewer cores. So if you see it as the 1.8% per core, then that will definitely go up. If you're asking about the median utilization of our entire capabilities, that's something that I can't predict. That's more to do with the usage on the system. And your second question, which my tired brain has now, can you jog my memory?
What do you expect to be the deflationary pressure?
The deflationary pressure. That's something, I mean, Jonas is an economist, so I think he could answer much better. But by burning the tokens, you're removing them from the ecosystem. And so if there are fewer tokens, then each token that's left is worth a little bit more. So instead of the number of tokens increasing, it's decreasing. So there's a kind of, I couldn't say by how much. I mean, there's definitely, you could make models, but I'm not sure that I could answer that. Yeah, that's kind of like the hatchet attempt at explaining that. So yeah, apologies for the kind of the little teasers of slides that I flicked through, but there's a few hours worth of talk in Coretime. So.